Hello everyone. Today in our syllabus we are going to see bioinformatics practical. I have already uploaded biophylogenetic analysis using Phylip. Just check it through your classroom work. Now next practical is basic structure visualization using deep view. So we can also call it as basic structure visualization with the help of SPD viewer. Okay, and we are going to perform basic tasks like selection, displaying structure, coloring, measuring distances, and labeling. Okay, so before that, before to work with the SPD viewer, we need to also see that the other software is also helpful in structure visualization. So and that the name of that software is Rasmol. So before to install the software, I'd like to show you how to install it. Just write down Rasmol software, okay, on the Google. You will get these first link, the Rasmol v2.7.5 to install. You just click on it. You will once you will click it, you will get this page, and just click on Rasmol 2.7.5 Windows installer. If you have a Windows system, just click it on that, or else if you have a other systems, just manually you need to uh, uh, install it. Okay, so this is the basic web page. So once I install it, I'll get this just a minute. This I have already installed it. So I'll get this data or this icon over here where I have installed several software. So I'll just click it on. So once I click it, you'll get this completely black window. So after that, you need to open the file. So what kind of file it actually takes? So before to show it, I'd like to tell you that it actually accepts, okay, it actually accepts CIF file or PDB file also. Okay, so let me just tell you, once you enter into the Rasmol file, open, yeah. So you can see here it's a Rasmol Raswin desktop file 5 ME, and you can download that format file from PDB. Okay, so how to download it? You will just do it. PDB. Okay, we'll go to protein data bank RCSB PDB. As far as I have already told you, there are different protein data banks are there, but out of that the PDB is the biggest data bank. And here I'll just write down if I wanted to see the hemoglobin alpha unit. Okay, there are four subunits, right? Alpha 1, alpha 2, beta 1, but other subunits are also there like epsilon, zeta, eta, something. I'll just check it down. No any entries coming up. Yeah, hemoglobin alpha. Okay, how to download? I guess the server is down, I guess, but how to download? We'll get back to this one. So before that, I will just show how exactly we take the protein. So suppose I have these 5me2, this kind of file right now with me. I'll just open it. Once I open it, I'll get this complete protein file. Okay, now with our cursor, with our pointer, okay, if you have a mouse or if you have a touchpad, you can just click on any spot and you can rotate. Okay, with a 3D fashion, you can rotate the whole uh, molecule. So this is the hemoglobin molecule itself. Okay, so this is the molecule I can rotate. Now currently it's the um, state of the compound is the wired. So if you want to change it, so just take out, this is the wireframe structure. If you want to change it, you just go about over here, can see, you just click on the display, and if you want to see the backbone, the whole structural backbone, you can see the whole chain, how exactly it is winded. Okay, and you can see where the helical structures are there, where the beta sheet structure, the maximum helical structures are there, okay, within this. If you want to see the stick model, it's a little bit confusing, right, to identify, but for some experimentation we need these kind of structure to understand where the elements are there. And if you see the space fill, then you can see the atoms, how exactly. So these kind of structure is very important for docking purpose. So the space where the energy, where energy is minimized, where the energy is high, where we can dock any chemical component, whether it is structurally compatible or not. So at that time we need space fill structure. And even though in the Ramchandran plot also we can say that we can the Ramchandran himself, they use that kind of model to understand the torsional angle, or to understand how angles they made. Then if you see the ball and stick model, that is quite easy. if you if you want to maximize these, or if you want to uh, what do we call it? There are different colors, different options are there. If you don't want to see hydrogens, the hydrogens bonds will disappear. If you want to see the hydrogens, the hydrogen bonds will appear. These different settings are there. You can what you can actually pick any bond or angle or torsion. You can even pick the distance. So just click on that particular what do we call atom, and you will see the distance. You can see here, see how much angstrom unit is see here, 1.52 angstrom unit. That is the what do we call, the distance between these two atoms. You just double click on any atom and you will get the distance from its previous atom, right? Again we'll get back to display. There are different things, like if you take an example, ribbon like a structure. So ribbon like a structure actually guides us or show us the beta sheets and alpha helical sheets, how many. So here in this amino acid there are maximum just helical structures are there, you can see here, is it? And the distance between T also, like see, we have already contributed the distance. Okay, so you just have to click one distance. Okay, here I'll just double click my right click. Okay, I'll just double click over here, and then I'll double click over here. It will, it's not working. Yeah, now 0.98 angstrom. You have to just you have to just how we have measured it, the whole distance. So we can measure the distance within the molecule with the help of this. Then the strands are there, strand like a structure. So these are the strands, how exactly we can check the protein, how it looks like. Okay, the bulgiest cartoon fashion, and then ultimately molecular. molecular surface. So this molecular surface is very important. That molecular surface is actually shows us, it is very important during the structural visualization, for energy capturing, or even though for docking also. Both thing we can actually accept. Just it will take a little bit time. Yeah, it is taking too much time now, I guess. Yeah, here you can see that how molecular surface is actually appears. This surface, that means it's the actual surface of that protein molecule, and the like we can say the imaginary solid surface where the electrons and the atoms can interact with each other. Okay, I hope so. You understood this tutorial about the Rasmol. We cannot modify or we cannot do any other operations. This is just to view the secondary structure or tertiary structure of protein molecule.